Okay, so we got two samples here. This one is sand. It happens to be black sand, I think, because there's a little bit of iron in it. So it's sand from a beach, but it's black sand. This one is salt. And you might notice here, this is a 100% pure black sand, 100% pure white salt. And I've weighed them out. It turns out there was about 60 grams, exactly 60 grams, I should say, of the sand, 40 grams of the salt. And again, I've got salt, I've got sand. They're both pure, and I'm here taking the lids off. Again, you can take a look. White salt, black sand, 60 grams of pure sand, 40 grams of pure salt. And now, how easy would it be to mix these together? I'm just going to pour the salt on top of the sand, and it's not very well mixed at the moment, but I'm just going to put this lid on, and I'm going to shake it around for maybe a little bit less than a minute or so until they are combined, and I've now got 100 grams total. The problem is it's not pure anymore. It's a mixture of 60% sand, 40% salt. So the idea is that this is normally how we find things in nature. We don't normally find things 100% pure in nature, rather raw materials, natural resources. They tend to be a mix of a lot of chemicals, kind of like this. There's valuable stuff in there. Salt we could put in our food, black sand that could be used for a bunch of different things. And yet we need to purify these substances. We need to get them apart. So it was so easy to mix them. And so it's so easy to mix the sand and the salt to get a mixture. What we're going to look at is getting them back apart, making the separation, recovering pure sand, pure salt from this mixture. So how are we going to do it, and what measurements are we going to take so that we can determine if we make a good separation or not? Okay, so before we actually do the experiment, we're going to get our data table ready. You want to get a pen, not a pencil, but a pen to do your data table, a ruler, or at least a straight edge to draw it out, and some blank paper, maybe some graph paper. Lined paper is not going to look so good. See if you can maybe some blank paper. Again, a pen, not a pencil, and a ruler. So we're going to draw out the data table. It's going to I'm going to show you how to do it in just a few moments here. And you want to make sure you do this. We're going to draw out the data table. It's going to have 2 columns and 3 rows, 6 squares. Your data table doesn't need to have the exact same measurements as mine. It's fine if you just, use a book edge as a straight edge to draw a nice data table and, make it nice and big. It should be about a whole page big. And now the idea as we move through the experiment, you want to write down the data that you see in the appropriate square of your data table. And I'm going to show you the answers at the end after the experiment so you can check that you have the right data. But go ahead with your pen. You want to first make this data table. You want to keep it handy and record down the measurements I make as we move through the experiment. Okay, so let's make our data table for the experiment. And let's see, I'll maybe make this about 5 inches wide. We're going to end up having 2 columns. About 6 inches on the vertical. Okay, now I'm going to complete the square here. And then let's mark off halfway, 2.5 inches. 2.5 inches. And I'm going to complete this. And then I'm going to mark off every 2 inches. Okay. And here we have a nice data table. And this side is going to be for the sand. The right side is going to be the salt. And, oops. We're going to put in this first row the container plus the material that we collected. And then this second line is going to be the empty container, and then I can subtract these two to get the weight of the material that we recovered. Okay, so before we get started with the experiment, we do need to have a safety discussion. Obviously, extremely important, perhaps the most important thing, that we stay safe while we are doing chemistry. So first of all, if you're just going to watch, that's fine. Go ahead and watch. You don't have to repeat the experiment at home. Maybe you're interested in repeating the experiment at home, so you definitely want to, be aware, kind of follow this safety advice as you set this up and do it. And, the main thing about experimenting is that you need to learn to be responsible for yourself. And being responsible for yourself in the chem lab basically has two components. First of all, if you need to know what you're doing, you need to understand what you're doing. We're going to be heating something in this experiment. Do not walk into the kitchen and just start playing with fire, right? That is a bad idea. You want to watch the videos. You want to understand what you're doing. You want to feel confident that you know what you're doing. And if you don't know what you're doing, don't do it. Ask for some help. You can always ask an adult who has some experience cooking in the kitchen, or you can email us. We're always helpful to fill in those little missing details that weren't clear. So if you're not confident, don't do it, right? Lab accidents happen when people are unsure, when they have doubt, when they don't know what's going on. This is when accidents happen, right? So watch the videos, understand what you're doing. Don't do it until you understand what you're doing. Now, the second thing I have to say about lab safety is, where are you doing this experiment? If it happens to be your kitchen with your heating element, with your cookware that you bought with your own money, fine. But if you're maybe in somebody else's kitchen, regardless of your age, if it's not your kitchen, if you live in somebody else's house, tell them what you're doing. Ask for permission before you do it, right? So be responsible, understand what you're doing, and ask for permission of the person's kitchen that you're going to be using. If you can't clearly explain to them what you are going to be doing in their kitchen, you're probably not as prepared for the experiment as you think you are, and perhaps you should kind of reconsider. Watch those videos again. Make sure you have it figured out before you get started. Okay, so that being said, the main thing we're going to do in this experiment is we're going to be heating some substances. Specifically, we're going to be heating some salt water, boiling off the water, and we're going to need some sort of heating element. And you can see here what I have is a pot on top of an electric burner. Now, this is exactly what you don't want to do. This thing is way too hot. There's an expression that says, don't cook a pot dry, don't boil a pot dry on the stovetop. That's essentially what we're trying to do. We're trying to dry things in this experiment. And this thing is going to be way too hot. I looked up a little data here, and it could very well be the case that if left unattended, this burner could get up to, say, 1,000 to 1500 in the Fahrenheit scale, maybe like 500 to 800 Celsius. That's way too hot. We only need to get up a little bit higher than the boiling point of water. And this, by the way, is an electric element. You know, we have some stovetops that have a flame. In a lab, we'd have a thing called a Bunsen burner. An open flame is going to be even hotter. It might be something like 2,700 to 3,600 on the Fahrenheit scale, maybe like 1,500 to 2,000 Celsius. Way too hot, right? So I'm going to set this aside. We do not want to be working on the stovetop. Rather, what we're going to do is work in maybe like a glass baking dish in the oven. We'll have a lot lower temperature in the oven, and even though the temperature is, quote, relatively lower, it's still going to be hot, right? The main thing is you want to make sure that you have some oven mitts while you handle things. Now, we're going to work with the oven on approximately medium heat. I would say that medium heat is approximately 300 to 350 on the Fahrenheit scale. That's about 150 to 175 on the Celsius scale. Now, for what it's worth, low oven heat is maybe 200 to 250 on the Fahrenheit scale, 90 to 120 on the Celsius scale. We maybe want to get up a little bit above the boiling point of water, so low heat might not quite do it. Medium heat's probably going to be a little better. Now, high oven heat, that's too hot, more like 400 to 450 on the Fahrenheit scale, maybe 200 to 230 on the Celsius scale, roughly speaking. So we want to work in the oven, maybe with a glass baking dish that's not going to go into meltdown or anything like that if it starts to get too hot. And we want to stay on medium heat, maybe even the low end of medium heat. Again, that's maybe like 300 to 350 on the Fahrenheit scale, 150 to 175 on the Celsius scale. Now, it's possible you actually have an oven thermometer to put in and monitor this temperature. It's not important to have a precise temperature measurement. It's just that we don't want to get too hot. And one thing to be aware of, that knob on the stove that tells you how hot it is, right? You can't trust that thing. You know, all stoves are a little bit different. So if you don't have an oven thermometer, you might err on the cool side, kind of start off with low heat, see if it's really low heat. You can always turn it up a little bit later, right? Just kind of be patient, err on the side of not overheating, kind of start low. You can crank it up a little higher if it's not working. So we're maybe going to have to bake our material in the oven for over an hour, and you know, you can sit there and watch it for an hour. That would be the extremely safe way to do it. A lot of times we maybe put things into the stove and are doing something else off to the side, even in another room of the house, right? Be aware there's usually a timer on the stove, or get a timer, set it for a half hour, set it for an hour, right? Don't fall asleep and let the oven run overnight, for example. That is not a safe situation. So have not too hot heat, medium heat on the oven. Make sure you use those oven mitts for handling this glass dish when it's hot. And I'd also, again, recommend having a timer so that you don't let this thing go maybe more than an hour or half hour without checking in, right? Just kind of being aware of what's going on, not letting it heat too hot. That is going to keep this experiment safe. Okay, and we are set up here to separate this mixture of black sand and white salt. I've got a filtration unit set up, and the basic idea is that we're going to use some water. I just have some plain old distilled water, maybe not tap water. You know, tap water would be fine at home, but use distilled water if you've got it. And the idea is that we would put some water in here, right? We're going to dissolve the salt. The sand is not going to dissolve, and I basically just have a coffee filter we're going to put on top of a funnel, and we're going to filter catching the sand on top, letting the salt water go down to the bottom. Now, a little thing about this sand, it's really, 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 really fine, and I found if I had, tried to dissolve the salt, it took a lot of water. The sand was then sticking to the sides of the biggest container, and to kind of clean everything out, I ended up really using a lot of water. So we're going to have a slightly modified approach here, and then I'm just going to put this mixture into the filter, the sand and the salt directly, and then I'm going to pour not cold water but some hot water that I've boiled in this water boiling electric kettle. I'm going to pour some hot water down through. It's going to dissolve the salt and go down to the bottom. We call that liquid the filtrate. And we're going to have the sand on top of the filter paper. So this is just a plain regular funnel, just a plain container. A plastic bottle would work fine. I've got a glass thing here that's maybe a little bit more heavy and sturdy that's not going to fall over on me. Now, common mistake is just to simply put the filter in the funnel. You might see that this is not very stable. The wind could kind of blow it off at this point. And so the little trick that we are going to do is I'm going to maybe, first of all, I'm going to fold this filter paper just a little bit so it has a little bit more of a cone shape to it that sort of better fits the funnel. And now we're going to pour just a slight amount of water onto this filter paper, and I'm not filtering anything, but rather I'm just trying to get the paper just a little bit wet so that it's going to stick cleanly to the sides, and you can see how the paper is up above the funnel level, right? It's pretty easy to get the paper down inside the funnel, and then the sand is going to go up over the paper and down the funnel, and that's not what we want. So you want to get that thing kind of stuck to the side, and then to kind of really keep it in place, so maybe sort of fold it over a little bit so we have a nice pocket. And of course the main thing is that the filter needs to sit on top without going down through. And we're going to take the view here. We've got the filter paper on the filter in the container, and now I've got this salt sand mixture that I'm carefully going to load into the filter. And it's possible that we didn't get it all. I'm maybe going to use the cool water, not the hot water for this, right? We need to pour some water through this anyhow, so we might as well use the water that we're rinsing with in order to start the filtration. So I'm going to set that aside for now. Let's put the cap on this cool water, and we're going to get started with the hot water here in just a second, but I sort of maybe tilt this down, and I think you can see there's a lot of black sand, but also a lot of white, maybe some of the larger salt crystals. We're going to pour slowly, and we can see the drip. Maybe give a little better view. We can see that it's dripping down. You can still maybe notice some liquid level on top, and this is going to take some time. We're going to be patient, and again, you want to be careful, especially if you're using hot or warm water. You can always just use cold water and be a little bit more patient. So I can see it starting to move down through the filter. I'm going to add a little more hot water, and we continue to filter, waiting for the drip, and we can see down in the bottom, I'm seeing no evidence of anything that's black. Looks like all the sand is staying on top of the filter, and we have here presumably salt water that's passing down through the filter, and I still maybe see a couple of those smaller salt crystals up top, of those larger salt crystals up top, and they're slowly dissolving as the hot water is passing down through the filter. So we're going to let this filter for a few more minutes. It's maybe going to take some 10 minutes or so of wait time until everything is down to the bottom. Okay, and it's looking pretty good. We're going to add a little bit more water. Allow this thing to keep filtering. This might do it, as we're patiently going to wait here a few minutes for this water to drain, and there's still the water level up pretty high in the funnel. I'm not sure if you can quite see the edge of the water or not, but we can see it dripping down. It's been going for maybe 10 minutes or so now. It's kind of about done. And again, I see no evidence of anything black down in the bottom. It's looking pretty black up top. I'm not seeing any evidence of salt remaining on the top. And it looks like it's just about done here. We'll take another look at this in just a moment. As I start to tilt it over, being careful not to tilt too far because I don't want to spill anything, but just to give you a look, it's looking pretty black in there. I'm not seeing a lot of those white crystals that were present initially, the salt. Okay, so now we are post-filtration. As you recall, we put the mixture of salt and sand on top. We poured hot water down through, and this is presumably our salt water in the bottom, and our sand is up top. And now it's not quite final product. It's all wet. We can't weigh it because it's going to have some water weight in there. And in fact, I've really let this thing just sit for maybe an hour or so, make sure that every last little drop of water has got down out of the funnel, mostly because I just don't want to make a mess. I'm pretty sure all the salt has been washed down, dissolved, and ended up on the bottom. So we want to figure out how much sand we have recovered, and we need to get a dry sand weight so that we can be sure that the water has not affected the measurement. So I can't just put this filter with the paper on my scale directly, one, because it's wet, two, because it's a mess and it's going to destroy the scale. So I'm going to slowly dry this in the oven in a small glass tray. We could just as easily set it outside now and let it dry in the sun. Now, the one thing we have to consider is whether the wind is going to blow some of that sand away as it dries. So I'm going to do this a little quicker in the oven. So essentially, I'm going to put the sand in this glass tray. We're going to cover it with this piece of aluminum foil. And then in the event that there is any water in there, just with a toothpick, I am going to poke a few holes in the aluminum foil so that this is going to be our tray that we use to dry off the sand. Now, little trick we're going to do here is I'm going to take the weight of this device, and it turns out that the glass tray with the aluminum foil, it's saying that we have 265 grams. I'm going to take a moment to note that that is the empty weight, and I'm not going to do this on the scale, but rather off the scale in case it's wet. I'm going to very carefully unload this filter paper, and you notice I've got this glass tray with some sides on it. I'm going to very carefully transfer this into the glass, making sure that I don't spill anything, so there's no sand in the funnel. The saltwater jar that we were using to filter happens to have a lid, so I'm going to close that for now. We will come back to the salt in a moment, but let's focus on the sand. And here it is. I'm not going to spill it. Be careful not to throw it too. Be careful not to tilt it too far, but that is the sand that happens to be black. And we're going to cover this up. And there is some paper in there. I don't want to heat it at a very high heat, but I'm just going to let this sit in the oven on medium heat for about an hour or so. Afterwards, we'll weigh it with the sand still in it, and we'll take the difference of those two numbers. It starts at 265 grams empty. We'll see what it weighs with dry sand in it. We'll subtract those two numbers, and we'll know exactly how many grams of sand that we recovered in our separation. You can hear it sizzle as it's releasing the water. This is the sand drying under medium heat. Okay, so the sand has come out of the oven. Now I've got the hot mitts. I did use them to get the sand out of the oven, but I just let it cool here for an hour or so that it's definitely cool to the touch. I don't want to be handling anything hot. Now we weighed the empty container with the aluminum foil. Before we put the sand in it, let's take another weight, and it looks like it is saying 330 grams, and I believe it was 265 grams before. Now it's 330 grams. It would seem that there's about an additional 65 grams of material inside. Now let's go ahead and take the lid off of our recovered sand. I didn't want to take the lid off before we weighed it because that is part of the weight. And let's take a look in here. It's looking pretty black, and yet I can see that there's a little bit of white crust, especially on the surface of the sand. And as I, maybe break a piece open, I can see there's a little bit of white material in there, and it looks like it is possible that there is still a little bit of salt mixed in with the sand. We didn't see it when it was wet before we put it in the oven. Perhaps the salt was dissolved, and now that it's dry, that salt has crystallized, and you can see it sort of stuck the sand into these, relatively hard rocks. I'm having a difficult time sort of breaking them apart. That's due to the crystals of salt that have sort of frozen all that sand together. Normally the sand would just be sort of sand and wouldn't be clumped up like that. So apparently we did not achieve a perfect situation. There's a lot of sand in there, but I can see that there is also a little bit of salt and that our separation is not perfect. Okay, and now we have our salt water that passed through the filter, the filtrate it would be called. I had put the lid on to keep it safe, and we are going to put it in this glass baking dish at medium high in the oven and cook off the water, crystallize the salt so that we can recover the salt. Now, one problem that is kind of common is that the salt is going to tend to splatter, so I'm going to fit some aluminum foil tightly on this glass baking dish here, and I've got a paper clip because we want to make some holes to allow the water that's boiling off to escape. So I'm going to put some holes in the aluminum foil, and it's empty. It's going to go in the oven like this, plus the water and salt. The water is going to cook out, and we're going to be left with salt in this dish. And the strategy here is I'd like to know how much this weighs. That way we can weigh it again after we take it out of the oven, subtract the two numbers, and have how much salt we've recovered. So let's take a look at how much this weighs, and it's telling us the dish plus the lid, the aluminum foil, we have 938 grams. So I'm going to note 938 grams. We'll certainly come back to that later. Now I'm going to carefully take the lid off And now we have our salt water, our filtrate. I'm going to pour it in. And the thing with separations, we don't want to lose anything along the way, is there's still a little bit of salt water. I can see even there's a drop down there. We'll get that last drop, right? But we still didn't get it all. I have here just some water, some plain distilled water, and I'm going to put a little water into this. And we're going to rinse it out. So we're getting a little bit more water that we need to cook off, but I want to make sure that we've got all the salt out of this first container and into the second container that's going to go in the oven. So I'm going to rinse this thing out maybe a few times with some clean water. And now at this point, there might still be a drop down there, but I'm hoping at this point that it's just water. We've got all the salt plus a lot of water into the dish. I'm going to put the lid back on, and again, it was 938 grams empty. We could weigh it right now to get a sense of how much water we have, but it doesn't really matter. The idea here is that I want to cook off all this water and then weigh it again after we are baking. So I'm going to take this over to the oven, and we're going to watch it cook for a minute before we take our next measurement. Okay, so the salt has presumably crystallized. I have taken it out of the oven after a little more than an hour and a half of heating at medium temperature. You saw it boiling away. You can still maybe see that evidence of the white salt crystals. And you see I just touched it. You see I've got my oven mitts here now. These are actually not going to be used, right? You don't want to handle this thing while it's hot. It obviously was very hot. I did use the oven mitts to take it out of the oven, and then I'm just going to let it air cool for maybe an hour or so until it's completely cool to the touch. And you notice that I haven't disturbed anything. Now, what we should do here, I want to take off the lid and take a look at this. If you remember, before we put it into the oven, we weighed the tray with the aluminum foil on. And before I take it off, before I kind of disturb anything, I've got my scale here, and let's just put this on the scale, and we are now up to 958 grams. So we've got 958 grams, and let's go ahead now and see what's under the lid. I'm still not going to destroy this in case it turns out I wasn't quite done. I could maybe put it back and try to finish up. But here is the crystallized salt, and as you can see, it's kind of spread in a thin layer on all the available surfaces. It kind of creeped up the side of the walls of this glass dish, and you can maybe imagine why you want to make sure that you have a lid, some aluminum foil, and yet, of course, the water does need to evaporate. We, of course, had the holes, and maybe even better evidence, I'll just turn this aluminum foil around, and this is all sorts of salt, the stuff that's more white, not shiny, that is salt. The shiny stuff more over here is aluminum foil, but there's a lot of salt. You know, we didn't weigh the aluminum foil, maybe not a gram of salt, but again, you could imagine that a lot of this salt was sort of jumping up out. So we've got our final weight, and now are we sure that this is really dry, that all the water is really gone? And you might ask, how can we account for that? How can we make sure it's really dry? And, you know, we've got the weight that, assuming that there's not any water in there, the only real thing we can do is put it back in the oven, let it heat again, see if any more water boils off. We'll just have to reweigh it. We'll just have to reweigh it and see if it gets any lighter. If it stays the same weight, then we finally know that we're done and we've got our salt crystallized. And again, I have a feeling that it's done. We're going to give it another try to make sure we maintain a stable weight, but you can see that this is pretty dry crystal. And note the strategy of weighing this empty dish, weighing the dish with the salt in it, including the aluminum, of course, because it is going to take a little bit of effort to scrape all that salt loose. If I wanted to scrape it loose and weigh it, we might end up losing a gram or so in the scraping process. So this method of weighing the dish before and after we crystallized is going to give us a better estimate of how much salt we really have. Okay, and let's try this again. It's been a few hours. I put it in the oven. I let it cool. I'm going to turn the scale on. It was at 958 grams, and we are still at 958 grams. So it is dry. It apparently was dry. I'm going to take off the lid and take a look, and it still looks like the same dry crystallized salt to me. So that is nice that we actually had it dry on the first try. But, like I said, you never really know what is going to happen until you weigh it, bake it again, reweigh it. You've got to get a stable weight. If it goes down by a gram or so, that means there's still some water that you're cooking off. And you kind of got to throw that measurement out and try a little bit harder to get that salt completely dry. So that's the process. We bake, cool, and weigh, and we repeat until we get the same weight, and that way we know that all the water is really gone from the salt. Okay, now I'm scraping here. I've taken off the lid and I'm scraping to recover the salt. If you recall, the empty container with the lid was 938 grams. We ended up with 958 grams with the salt. So by difference, we should have 20 grams worth of salt. So let's scrape it down here and sort of take a final weight, see if we've really been able to recover anything. And I'm going to turn on the scale. Normally, I would put a piece of paper on the scale to weigh the salt. That's going to result in white salt on white paper. So I've got a little piece of aluminum foil that's going to serve as the weighing paper. And I'm going to put it in and zero out the scale, but I see that this piece of aluminum foil is less than a gram, and it's not registering any weight on the scale. So I'm maybe going to fold it just a couple times to make a little bit of a pocket. And here we go, as the salt is coming down onto the paper. We'll get a little bit more, and here is our final recovered salt product. Now let's put it on the scale, and again, we are expecting to have 20 grams of salt, and the scale is telling us that there's actually 19 grams of salt here. So what's going on? Are we a gram short? Could the scale possibly be off by a gram? Now, as we sort of look at the container, we can see maybe I didn't do exactly a perfect job of scraping it clean. And there's also a little bit of salt kind of dusting the lid of the container as well that we had put in the oven. And, you know, I could maybe continue to scrape here and try to get it. I'm not sure if I'd ever really be able to get it all. You know, maybe the only solution is to add some water, redissolve the salt, and then recrystallize it, but we'd pretty much be right back in the situation where we started from. And this is actually just a general chemical principle. Again, I could have done a little bit of a better job of scraping it clean, and yet no separation is ever going to be perfect. You're always going to lose a little bit as you go along the way, and even in that sort of final transfer here, it's quite possible that we might have lost a gram or so of the salt that we produce. So nonetheless, here is our final salt product, about 19 grams worth of salt. Okay, and so we are all done with the salt-sand separation. Again, the idea was that you had made that empty data table and recorded the measurements in pen as we were going through the video. So if you didn't do that, why don't you go back, make your data table, fill it in just a moment here. I'm going to show you the right answers to make sure that you have all the measurements in the right place, but give it a try for yourself, and note that the data table is nice and big. It's fine if you make a mistake. You might notice I made a mistake here and I just crossed it out so that I can still read it, and I kept going, right? There's plenty of space in these squares to make an error or two and corrections, and we want to do it in pen. It's fine if you make a mistake. Don't obliterate it. Just kind of put a line through it, put the right answer somewhere in the box where it belongs. So here we go. We're going to look at these data in just a moment. So on the sand side, there were 330 grams of the container plus the dry sand, and we had weighed it before when it was empty. It was 265 grams. So I want to subtract these two numbers, and it looks like we recovered 65 grams of weight total on the sand side, and on the salt side, after we took it out of the oven, it was 958 grams. The empty mass was 930 grams. And again, if I subtract these two numbers, I note that we have 20 grams on the salt side collected. Now, one more thing that we might note down here is the total weight collected at the end. And if we add these two numbers together, we note that we have 85 grams, and this doesn't really belong to either column. I'm just going to kind of tack it on to the bottom of the data sheet, and I'll even make this line maybe a sort of a double line so we can see that the data ended and the total amount collected was 85 grams. Okay, so we have our data recorded. The experiment is finished. It's obviously not a perfect result, and yet that's the way experiments go. The result is never quite perfect. The idea now is that you might think a little bit about what really happened, what wasn't exactly perfect about this experiment, and maybe even how you could do it better if you'd come up with a new procedure, even a new data table, if there was anything maybe that was missed in the experiment that you would have included. And specifically, a couple things to note. First of all, we started off, with 100 grams of material. we ended up with 85 grams. So did we lose 15 grams along the way? What was the nature of this lost material? You'll notice that the sand, we started off with 60 grams of sand. We ended up with 65 grams. We maybe saw that it isn't quite pure. So, what exactly does that mean? What exactly is in there that's not sand, and how much? On the other hand, we saw the salt. Was it perhaps more pure than the sand? And yet we started off weighing 40 grams of salt. We ended up with 20, so that seems a little bit low. Can we explain that? Where did the salt, where did the sand end up, and why is that total at the end less than we started with? So these are kind of the questions to address for this experiment. And if you're interested at some point at making a lab report out of this experiment, you've got the data. These questions that I just posed would be the type of material that we would discuss in a lab report, and again, perhaps coming up with some ideas what you might do a little bit differently to make the experiment work out better. Okay, and let's take a look here at an interesting difference in the physical properties, the difference between salt and sand. And I have here a surface covered with aluminum foil because I thought it might show up a little bit better. We have a pile of sand. I put this out yesterday, and as you can see, the sand is still pretty dry. Now, the salt, on the other hand, you can maybe see is very, very wet. You can even see that there's maybe kind of a puddle of water down here in the middle of the salt. And what's going on is that the salt is what we call a hygroscopic material. And this is a big word, but all that it means is simply that the salt absorbs water out of the atmosphere. The humidity condenses onto the salt, dissolving some of the salt, and you can even see evidence of all that water. It's wet down there. I guess that would be an aqueous solution of salt water, right? We know that salt dissolves in water, and not only will salt dissolve in water, but it's basically going to absorb humidity out of the atmosphere such that it dissolves. Now, the sand is not a hygroscopic material. It remains dry. And as a little further evidence here, you can see this mortar and pestle that I had used to break down the salt. It was in kind of larger rocks of salt. I used the mortar and pestle to break it down before the experiment. You can see some evidence of water down in the bottom. And note here, right, that this salt has absorbed water. I did this yesterday. I let it sit out. The mortar and pestle is wet. You can see that the water has soaked in to this part, up. The tip remains dry. This is, I believe, made out of a volcanic rock. It's really porous. And again, the salt absorbed water out of the atmosphere. The humidity condensed, wetting the salt, and the water proceeded to wet most of the mortar and pestle. And, this all happened in some hours, less than a day for sure. So this is just a thing about salt and a lot of chemicals in general. They're hygroscopic, right? They absorb water right out of the atmosphere and you don't see it. But sometimes it turns out that when we do a chemistry experiment, what we thought we had wasn't exactly what we thought we had because there was a lot of water weight in there. And you might you might remember at the very beginning of the experiment, I had measured out 60 grams of sand, 40 grams of salt. Now, I had never showed you drying that 100 grams of material. It was, in fact, not dry. So it may have turned out that there was some water weight included in that experiment, and I'll just kind of leave that for you to think about, whether it was the sand, the salt that might have had some water content at the beginning of the experiment that wasn't accounted for, and if we could maybe estimate how much water there was at the beginning.